All right, so 3, 2. So find the degree and the leading coefficient of f of x equals 3x to the fourth plus 7x minus 5. So what the degree means, the degree is the highest exponent. Those of you who took intermediate algebra, this should be a review. If you didn't take intermediate algebra, it should be a review from algebra 2, algebra 1, all that good stuff. So the degree is the highest exponent. So looking at this, what is our degree? 4. That's it. And the leading coefficient is going to be that number out front of the leading term. The leading term is the term with the highest exponent. Yeah, 3. So is the number in front of term with highest exponent. And remember, this is called the leading term. But anyways, our leading coefficient, yes, would be that 3. Leading coefficient will be 3. So that's it. Found the degree, found the leading coefficient. How could I help you? What questions do you have for me? If not, let's do the next one. So find the degree again and the leading coefficient. This one's a little bit more challenging, so be careful because it's not multiplied all out for us. But if we were to multiply all this out, what would be our degree?
X to the fifth.
X to the fifth, good. So I have 3 x's here. Times 1 more x would be 4 x's. Times 1 more x would be 5 x's. Remember our properties of exponents. Whenever we're multiplying, we're going to add up all the exponents. So our degree would be 5. So this would be x cubed times x to the first times x to the first, which would give us x to the 5th power. If we were to distribute all of this. So that's our degree. What about our leading coefficient? Same thing. You have to think about if we were to distribute.
10.
Close.
Negative 10.
Close. Just the leading coefficient. So just the number out front of the x to the 5th term. What? Negative 2. Good, thank you. Negative 2, yeah, because it's negative 2x cubed times x would be negative 2x to the 4th times another x would be negative 2x to the 5th. So it's still just going to be negative 2. So if you want to think about it as negative 2x cubed times x is negative 2x to the 5th. So you want to put a little negative 2 out there. So just the numbers outside of the highest exponent. And that was the hardest one I could find, the trickiest one I could find. So questions, comments, concerns for me. The leading exponent and the degree tells a lot about the graph. So that's what we're going to do next with this. But any questions on identifying the leading coefficient and the degree? Yes, sir.
Explain to me, please, how finding the degree with this problem is different than the previous problem.
Gotcha. So do you see how this one's already in like standard form for us, or already in general form where it's already all multiplied out for us? So it's just this term plus this term plus this term. So that was easy. I could say, okay, this is the leading term. That's my degree. That's my coefficient. Done. Over here, they didn't put it in general form for us. They didn't distribute everything out for us nicely. I have this term times this term times this term. So because they're being multiplied, I had to pretend that if I were to multiply all this out, then what would be and it would be just like number 1 then. Then how would you find your degree? Does that make sense?
Yes.
Thank you for asking a question. So because you have to multiply those, that's why we had to go a little bit further with the work. These were already all multiplied out for us. All right. So, as I said before, that the degree and the leading coefficient tell us a lot about our graph. So it tells us what's called our end behavior. It tells us what the ends of our graph are looking like, whether they're both going in the same direction, whether they're going opposite directions, whatever the case may be. So looking at this, the graph of x squared, what does that look like? An upward parabola, good. So it looks like this. So on my left side, my left end behavior, what is this left arrow doing?
Rising.
Rising, good. So it rises to the left. Same concept. What is it doing to the right?
Rising.
Rises, good. So it rises to the left, rises to the right. Never mind. What is negative x squared doing?
Going down.
Yeah.
Well,
So it's a parabola going downward. So what is this left arrow doing?
well,
Falls, good.
well.
So falls and falls. Falls to the left, falls to the right.
Are you thinking about that song?
Yes, are you thinking about that song too? I almost embarrassed myself by saying something, but I was like, no, forget it. Don't say it, Lainey. Hold back, hold back. Okay, so x cubed. What does x cubed look like?
An S.
Yeah, kind of like the little like curvy S, something like this. Notice, kind of, not really, but kind of.
Oh, yeah, mine
Okay, fine. You're making me self-conscious.
is.
Have to use some whiteout. Better?
No.
Yeah. Meh. All right. So notice my biggest thing that helps me is it's positive, so it kind of has like a positive slope. Positive slope. It's kind of like going. Okay, so it's
Yeah.
it's kind of like rising, right? So it's going. So the left arrow is falling. It's going down. Falls to the left, but the right arrow rises to the right. So negative x cubed would be the opposite. Good. So it's kind of like going. Ooh.
That's great.
Yeah. All right. So what is this left arrow doing?
Rising.
Rises, and the right arrow
Falling.
falling. Rise to the left, fall to the right. All right, so what is this called? This is called end behavior. Because we're looking to see what is the ends of our graph doing. What are the ends of our graph doing?
Is it like as of the rise and fall thing? Will it
Yeah.
get harder? Like.
No.
Okay.
Yeah, okay. So with that being said, though, this is end behavior. This is it. So let's come up with like some type of generalized thing that could help us say, okay, based off the degree and the leading coefficient, I can see, okay, what are the ends of the graph doing? So what do you notice about whenever it's squared?
They're the same.
Yeah, the same thing, right? So even degree, you just read my mind, even degree has the same thing. So even degree, same direction. So with that being said, if it has an odd degree, not the same, different, opposite. What about odd and opposite? Because both O's. No? Are you kidding me? Oh no, yeah, I don't like that. Okay, so what do you like?
Different.
Different, fine.
Or not the same.
I can't even spell different.
That says direction.
There.
It's because you're different.
I know exactly. Maybe that's trying to tell me something. Different direction.
Oh, yeah,
What?
you're recording.
Oh, it's okay. Whoever's watching my videos knows I'm
Did
different.
you write
Did you write not the same? I would have wrote opposite because odd and opposite, they both have O's.
Because you're odd.
Yeah, because I'm odd, exactly. All right, so what about leading coefficients? So that's telling me, okay, they both going the same, both going different, but now you see how they both going up, both going down. So if we have a positive leading coefficient, so it starts going upward. Oh, well, so it rises.
No, it doesn't.
Okay, that's okay.
No, it doesn't.
Okay, let's do this.
Okay.
Let's make a what is that thing called? Like a Punnett square?
Yeah.
Yeah, let's make a box. Let's just
Okay.
okay. So let's do even, and let's do odd, and then we could do positive and negative. So this will be better, I think. This is where I was going with it, and I didn't go there. So even and positives, up and up. Odd and positive is down and then up. Even and negative is down and down. Odd and negative is up and down. That's all I have to know. So this is our leading, wow, that hurt my head, coefficient. And this is the degree. I like that better. That's more organized and straightforward. So those are your four options based on even or odd degree, even or odd exponent, and positive or negative leading coefficient. So it's pretty cool. So just by looking at the graph, we could see our degree and end behavior. And so just by looking, we can see our degree and leading coefficient. And just by looking at our degree and leading coefficient, we can automatically see our end behavior. So that's like a big deal with our characteristics of our graph. That really tells us what the outsides are doing. All we have to do now is figure out what the inside's doing. Questions, comments, concerns for me, please. Yes, sir.
What song were you thinking about when you're talking about?
Oh. What is it called? The Cupid Shuffle?
Yeah.
Yeah. What? I don't remember what it says.
Slide.
Slide to the left. Yeah, slide to the right.
Crisscross.
Rises to the left. Yeah, so you know, everyone knows that song. Are you kidding me?
I haven't
You
heard
did-
that in a while.
Yeah. And he was like, everybody clap your hands.
No.
Yeah. That's all I'm saying. That's all you get.
Once you left the-
Now do you see what I'm saying, though? No. Okay, forget it. Never mind. What? I don't even want to know. Never mind. All right, so next example. Let me change something before I embarrass myself even more. All right, so use the leading coefficient test, which is the stuff that we've been doing to see what is the leading coefficient and the degree and all that good stuff, to determine the end behavior of the graph given the following polynomial function. Use this end behavior to match the polynomial with its graph. So going back to matching, we have, let's label this as A, B, C, and D. And then we have 1, 2, 3, and 4 for our equation. So looking at our equations, we can see, okay, what is our end behavior? Match the end behavior with the graph. So number 1, what is my degree? Degree. 4. Now, leading coefficient.
Negative 1.
Good, negative 1. So if it's an even degree, negative leading coefficient, we know it's both going downward. Notice I left the middle like empty, so I don't know what's happening in the middle. So which letter is that? C? Done.
Yeah.
What about number 2? What's my degree?
3.
3, good, leading coefficient.
1.
1, positive 1. So this time we're looking at odd degree, positive, so it's down and then up. So it's A, perfect, thank you. So A's done, C's done. Number 3, degree.
3.
3, good. My highest exponent is 3. Maybe I should be circling these. Good. My leading coefficient is -1. So I have odd degree, negative leading coefficient, so it's going up and then down, rises and then falls. B.
B. So when it's cubed, or when the exponent is odd,
Yeah, when the exponent's odd.
if there's a negative, then it goes up first, and if there's positive, then it goes down first.
Right. So the way I think about it is it's end behavior, so look at the end thing. So if this is positive, my end one is going up. If it's negative, my end one is going down. I don't know, it's weird.
That's good.
Good? You like it?
Yeah.
Cool, thanks. All right, so last one number. Well, obviously we know the last one's D, but for note's sake, what's our degree?
2.
2, good. Leading coefficient,
1.
good. +1.
Yeah.
So we know it's even. So we know it's both going the same direction, and positive. So we know it's both going upward, which is letter D. How could I help you? What questions do you have for me? So it's pretty fast of like, okay, look, just looking at it, no work. You can see what the graph looks like. So that's pretty cool. All right, so if we don't have any questions, let's go on to the next page. All right, so it says if R is a 0, so pausing for a second, what did we say zeros were? What's a 0 of a function?
X and
Yeah, good, the X-intercept. X-intercept. So if R is of even multiplicity, so I'll come back to that word in a second because that's a new word. If R is even multiplicity, then the graph touches the x-axis and turns. So it touches and turns at R. So multiplicity means how many times is this 0? How many times is x-intercept occurring? So for example, if we're looking at f of x equals x squared, right? So I know that the graph of this function looks like this. So notice at my 0, at my x-intercept, it touches the x-axis and then turns back up. Another word that I see other textbooks using is it bounces. So what is that called? Pinball? Where it like hits it and bounces back up. Is that pinball? No. I'm just kidding. Kind of like ping pong.
It's kind of like ping pong.
I'm just kidding. But you know what I'm talking about? Like it like hits it and then it shoots back up. So it touches and turns. So there's a 0. There's an x-intercept at x equals 0. And at that point, it touches and turns. So it's even multiplicity that occurs twice because of that exponent. So likewise, if R is a 0 of odd multiplicity, then the graph crosses the x-axis at R. So another example of that one would be f of x equals x cubed. So that 0 is occurring 3 times. So it's odd multiplicity. And we know it looks something like this. So my 0, my x-intercept, is at, again, x equals 0. There's odd multiplicity. So crosses x-axis. Oops. So based off of the multiplicity is how many times it occurs. Based off that exponent, how many times that 0 occurs. It's either going to touch and turn and bounce off if it's even, or it's going to cross through if it's odd. Another characteristic that we can easily find, another easy characteristic of our graph. So we know what the ends look like, and this kind of helps us figure out what the middle looks like. We can find the zeros, but now seeing what the zeros do. Questions, comments, concerns for me? We're going to do some examples next. All right, so let's do an example. So find the zeros of the polynomial function. So we found x-intercepts. That's what we've been doing. Give the multiplicity for each. So how many times does it occur? And then based off the multiplicity, we're going to state whether it crosses the x-axis or touches and turns the x-axis at each 0. So we're going to find the 0. We're going to find the x-intercept. How do we do that?
Plug in 0 for y.
Good. Plug in 0 for y. So 0 equals 2 times x plus 9 times x plus 6 squared. My math lab was finally nice for once, and it gave it to us factored for one of them, of course. So we can just set each factor equal to 0. So 2 is a factor, so 2 equals 0. X plus 9 equals 0. And x plus 6 equals 0. We'll come back and deal with the squared thing in a second. 2 equals 0. Does that tell me anything about x? Does that even make sense? No, so I don't even care. X plus 9 equals 0. Will give me x equals -9. And x equals -6 for x plus 6 equals 0. So those are my two zeros. Pausing for a second. We good? All right, so we found the zeros. And then it says give the multiplicity for each. So how many times is x plus 9 occurring as a factor, as a 0? Once. We just have 1 as an exponent. So this multiplicity is 1. Multiplicity. There you go. 1. Don't act like you don't do that. Multiplicity. Well, you guys already know I'm weird, so there's no hiding it anymore. All right, so x plus 6, how many times does that factor occur? 2. Good, so that multiplicity is 2. So looking at x equals -9, looking at that 0, we know the multiplicity is 1. 1's odd, so is it going to cross or is it going to touch and turn at that point? Cross, good. Odd, so crosses x-axis. That's done. Oh, are you kidding me? Oh boy.
Where did the multiplicity come from?
From the exponent. So it's that factor is occurring 1 time. X plus 9 to the first power. So I know my multiplicity is 1. It's telling me how many times it's occurring. X plus 6 is occurring twice because it's squared.
Okay.
So multiplicity is 2. All right, so for x equals -6 for that 0, that multiplicity is 2, which is even. So what's going to happen there? Yeah, it's going to bounce. It's going to touch. So touches and turns at x-axis. Yep. You can write bounce. My math lab in this textbook just uses touch and turn as the words. Same thing. One thing that kind of helps me remember it, though, is touches and turns is doing 2 things. Choose even. Crosses is doing 1 thing. 1's odd. Like it or leave it. That's what helps me. Oh boy, so just when we thought we were getting good and things were easy, they throw us example B. So same concept, we're still going to find the zeros, we're still going to find the multiplicity, we're still going to find out whether the graph crosses or touches and turns, but this time we have to factor it. So just one little extra step. So example B says f of x equals x cubed minus 6x squared plus 9x. So our first step in factoring is GCF. X. Yep. So our GCF is going to be x. So we have x squared minus 6x plus 9 left over. A is 1, B is negative 6, C is 9. We're looking for two numbers that multiply together to give us A times C, which is 9, and the same two numbers to add together to give me B, which is negative 6. Good, negative 3 and negative 3. So bringing down our GCF, we have f of x equals x times x minus 3 times x minus 3. Because A is 1, I can go ahead and go straight to my factors. How could I rewrite this neater?
X times x minus 3 squared.
Good, so f of x equals x times x minus 3 squared. So now I have it factored, so we can set each factor equal to 0. So this time we have x equals 0 and x minus 3 equals 0. For x equals 0, how many times is that occurring? What's our multiplicity?
1.
Good, 1. For x minus 3 equals 0, I need to solve for x, so I'm going to add 3 to both sides, so I get x equals 3. How many times is that occurring? What's my multiplicity? 2, good. So we found the zeros, we found the multiplicity, and now we're trying to find what happens. So x equals 0. Our multiplicity is 1, which is odd. So what's going to happen? Good, crosses x-axis at that point. At x equals 3, our multiplicity is 2, which is even, so what's going to happen? Good, bounce or touch and turn. That's it. What questions or comments or concerns do you have for me? Please.
You would have want questions. Why are you asking?
I do want questions. What did you say? I
It's
thought
like
I
you're
heard.
begging us to ask you questions.
Yeah, I do want questions.
Doesn't that kind of stress you?
Does that stress me? It stresses me if you don't ask questions because I know you have questions, but I know you're just not asking them. Or do you not have any questions? Yeah, you do? No. Yes, no.
Yes,
Now that
you
stresses
have
me.
questions.
Is it yes or is it no? I want to help you. So helping you doesn't stress me out. It kind of stresses me asking every 2 seconds, but I want to make sure that you have the opportunity.
How's that make you feel?
I'm not very good about talking about my feelings. You guys make fun of me, so. Now I make fun of myself. That's okay. How else are we going to do math for this long? Ready? Next page.
Yes, sir.
Okay, last page for this section. So 2 more examples. Putting it all together. Yay. So this time we're going to determine the end behavior, the intercepts, the zeros, including the multiplicity, and the symmetry. Then we're going to graph the function. So it's kind of like putting section 3.1 together with 3.2. So, biggest thing, please make sure you read the directions to know that you don't miss anything. So the first thing we have is our end behavior. For our end behavior, we need to know the degree and we need to know the leading coefficient. So this one is not multiplied all out for us. So if it was multiplied all out for us, what would be our highest exponent?
4.
Good. So we have x squared times another x times another x. which would give us x to the fourth. So our degree is 4. What about leading coefficient?
1.
1. Good, same concept. 1x squared times 1x times 1x will give us a leading coefficient of 1. So our degree is 4, which is even. Our leading coefficient is 1, which is odd. So what is our end behavior going to look like? Yeah, rising, rising. So rises to the left. Rises to the right. Don't even. You know whenever you're doing your homework, you're going to be like, rises to the left, rises to the right. I was always like, never mind, never mind. No, it's okay.
You bring it up, then you can't.
Because sometimes it takes me a minute to think about my left and my right, so then I'll like go the wrong way, then hit the person next to me, and it's like so embarrassing. Just kidding.
Sure.
Yeah. No. If I'm doing the Cupid shuffle, I'm probably not okay. All right, so end behavior. Next, looking at X-intercepts. You know what's going on in Pandora next class. Y-intercept. I'll make you do it for extra credit. No, I'll make it for a quiz grade.
Dance?
Yeah, did the Cupid shuffle.
Oh, it's fine.
All right, so X-intercepts.
That's easy.
So we know for our X-intercepts, our Y value is 0. Thankfully, it's already factored for us, so they kind of did the hard part. So 0 equals x minus 3 squared times x plus 2 times x minus 1. It's already factored for us, so we're going to set each factor equal to 0. Every time I see equals 0, it looks like an emoji. Like an old emoji. So x minus 3 equals 0, x plus 2 equals 0, and x minus 1 equals 0. Was it even called an emoji back then? Oh, it was called a face? Okay, fine. Yeah, smiley or something. Yeah, I know. Once you see it, it's like always there. Sorry. So we have x minus 3 equals 0. Solving that, getting x by itself, we get x equals 3. X plus 2 equals 0. Solving that, we get x equals negative 2. X minus 1 equals 0. Solving that, we get x equals 1. So those are our x-intercepts. Depending on if it wants it as a point, we'd have 3, 0, negative 2, 0, and 1, 0. I'm going to go ahead and plot those. So 3, 0, negative 2, 0, and 1, 0. All right, so now our y-intercept, which is easier. We know our x value is 0. So f of 0 equals 0 minus 3 squared times 0 plus 2. I don't know why I'm running it. 0 minus 1. So negative 18?
Yeah.
So 0, negative 18 is that point. So we can just pretend it's like somewhere down here. So we found our intercepts. Now it asks us to find our zeros. I already did that. Or we already did that. That's our zeros over here. That's our x-intercepts. But it also asks us to find the multiplicity. So for x equals 3, how many times did that factor occur?
2.
2. So our multiplicity is even, is 2. So we know it's going to touch and turn. For x equals negative 2, how many times that factor occurred?
1.
1 time. Good. So our multiplicity is 1. So we know it crosses at that point. And lastly, for x equals positive 1, how many times did that factor occur?
1
Just 1 time. So our multiplicity is 1.
crosses.
Again, so it crosses. And we got that from our exponent. So x plus 2 occurred once, x minus 1 occurred once, x minus 3 was written twice, so we had it squared. Oh, man. Symmetry. All right. So, for symmetry.
Wait, so do we have to do the,
Yes.
yeah, okay.
The
X thing where you plug it in, you put the negative, see if it's, and then it'll,
Oh.
yeah.
Yep, so for y-axis symmetry, we're going to plug in negative x and see if we get the original equation out. All right, so y equals negative x minus 3 squared times negative x plus 2 times negative x minus 1. Can't get rid of those negatives, so not original, so y-axis did not work. Same concept for testing x-axis symmetry. This time we're going to plug in negative y and see if we get the original out. So negative y equals x minus 3 squared times x plus 2 times x minus 1. Again, I can't get rid of that negative, so that's not the original. So not y-axis, not x-axis, but now it's test the origin. So plugging in both. And if you can just, I'm just doing this, writing it all out for our note's sake. If you can look at it, that's totally fine with me. As long as on the test you can show me how you got that answer. So negative y equals negative x minus 3 squared negative x plus 2 times negative x minus 1. Can't get rid of all these negatives, so it's not the original. So no symmetry. So basically that tells me it's going to be like a wacky looking graph.
So, do we just,
Like connect the dots? Yeah, pretty much that's all we're going to do. All right, so looking at this, I know a couple things. That the end behavior, so both of my ends of my graph are going to go upward. And I know at x equals 3, it has a multiplicity of 2, so it touches and turns. So it's going to hit there and then go back up. Bounce. Fine. At negative 2, right here, I know it's going to cross, and it's going to go down to this y-intercept. And at 1, it's also going to cross, so it's going to go through there. So let's go ahead and connect these pieces here, and then something like connect those pieces. We're just sketching it. We can use our calculator to get a more accurate graph.
Beautiful.
Thank you. Even though I know you're being sarcastic. So do you see how I use the pieces of the characteristics of our graph to put everything together without plotting a whole bunch of points? So again, my end behavior, I knew that both ends went upward. I know that we plotted all the points, the x-intercepts, y-intercept. At 3, we know it had multiplicity of 2, so it touched and turned there. At 1, it crossed through. Oops. At negative 2, it crossed through. Connecting the dots. That's our graph. Questions, comments, concerns for me?
Between the 1 and 3, how do we know that went up 2?
I just know it went up. I don't know how far. We're just sketching it. We can use our calculator. I mean, good point. But. All right, so last one. It says the graph at the right is a complete graph. That is, it's continuous and displays the function's end behavior. So we know it's going downward for both. All the zeros are integers, meaning they're whole numbers. Answer the following questions. Write the equation expressed as a product of factors of the following polynomial function that might represent the graph shown. Use a leading coefficient of 1 and make the degree f as small as possible. So what does the graph tell you? Help me out. What do you see by this graph?
Well, the zeros are 2 and negative 4.
Okay, let's start off with the zeros. So our zeros
Or 2 and negative 4.
are x equals, positive 2 and negative 4. So if we were to write those as working backwards here, writing those as factors,
X
Ooh.
minus 2.
Yeah. X minus 2 and what else? X plus 4, good. X minus 2 and x plus 4. All right, so at x equals positive 2, is it touch and turn or does it cross through? Touches and turns.
So
Which means?
Squared.
Yeah, so it's even multiplicity.
Yeah.
So it bounces.
Yeah, that.
Even multiplicity. So notice it says make the degree as small as possible. So it's our smallest even number? 2. So we know, so it has an exponent of 2. If it's 0, it wouldn't be a 0. X plus 4. Looking at that factor, looking at that 0. Same thing. Yeah, bounces or touches and turns. Turns, so even. Multiplicity, so exponent of 2, again, our smallest even number. So x minus 2 squared, x plus 4 squared. What else do you see? So we found the zeros, we found if it touches and turns, all that good stuff. What else does the graph tell you? Someone else said something about positive and positive, so it falls and falls. And behavior falls to the left, falls to the right. So we know it's both going downward. So what does that tell me?
But it's negative.
Negative leading coefficient, and even degree. Good. Negative leading coefficient and even degree. So it said make our leading coefficient 1, but we know it has to be negative, so we can make it negative 1 out front. What's our degree of this thing if we were to multiply everything all out?
X to the 4th.
4, good. So our degree is 4, which is even, so that's good to go. All right, so it said leave it as a product of factors. We dealt with the negative, we dealt with everything, we're done. So our final answer is f of x equals negative 1, so we can go downward. X minus 2 squared, x plus 4 squared. So that is 3.2.